So now in this video we're going to simulate using a lithium ion battery to light a 5 volt 1 watt LED for the most part. One problem is that if you're using a lithium ion battery, well, a single cell I should say, you have 4.2 volts at its maximum, which still will light the LED pretty good even though it's a 5 volts. But a fair amount of current will still flow at 3 volts through the high wattage LED. And so we want to limit the current more than that. We're going to use the transistor for that. We need to drop enough voltage from base to emitter right there, because a little bit of base to emitter current allows a lot more collector to emitter current. So if we can drop enough voltage, no current will flow base to emitter, and thus no current will flow from collector to emitter, and that LED will be completely off if we cut the current completely by cutting enough voltage. So I have one LED where I need the Schottky diode, the green LED that I'm going to use, and I have a blue LED where I don't need the Schottky diode. We can bypass it and get close to the same result right there. So it's kind of iffy when you're at low current how much semiconductors are going to drop voltage. It's kind of iffy at low currents. It's definitely lower though at low currents than what the voltage drop will be at higher currents. The Schottky diode I'm using is the 1N6263. So now we zoomed into the circuit there. There's the Schottky diode. You use it forward bias. The black band, the cathode, is more negative right there. So a Schottky diode, it's like a silicon diode, except for it drops about 0.3 volts instead of about 0.7 volts. So not quite as much. But in any case, we got a little current flowing, and you can see that the bright light is on a bit. If I drop a tenth of a volt, it gets a lot dimmer, and we got less than about 1 milliamp of current flowing through. Main thing though is we want to try to basically cut off current completely by about 2.5 volts. So we got a little trickle. So this isn't perfect. You won't want to make this your only protection for a battery, but we'll jump up to 4 volts. There you can see how bright it is, and you can see how much more current we have if we had a fully charged lithium ion battery. And even 4 volts, a lot of current is very bright, and we can go down to, that's about half the charge of a lithium ion battery when it drops to about 3.6 volts from 4.2 volts. And then you want it to hopefully cut off completely at 3 volts. Doesn't do that perfectly, but we'll see how much worse it would be without the Schottky diode right there. So quite a bit worse. We needed that little extra voltage drop, but at 3 volts with the Schottky, you don't actually need the Schottky with the blue LED for some reason. Right there, it's off, and we'll bypass the Schottky. So I mean, there's a little bit of glow. There's a little current flowing. This isn't perfect, but it's a lot better than no protection at all. And we will go up, and you can see now it starts lighting up. We're bypassing the Schottky. I can remove the Schottky now. And we looked at with the green LED. For some reason the green LED needed it. The blue didn't. Maybe other blue LEDs will act more like the green one. I don't know if blue and green have different forward voltages at very low current or not. So that's why I put in the diagram. Maybe you'll need the Schottky, maybe you won't for the most part. But there we go, 3 volts. And I'll zoom back in so we can see this a little bit better. You can see it's to the positive supply over there. That's going to the base. This is a 2N2222. Don't use a 2N3904 with this. It has a maximum current of 200 milliamps, and that's absolute max. And there you can see we're about 150. The 2N2222 can handle about 600 milliamps of current. So for this much current, don't use one that can only handle NPN bipolar junction transistor. That can only handle 200 milliamps of current. It'll be more likely to burn out. And one more thing before we go. I put the green LED back with the Schottky diode. You can see the amount of current that we're getting. Less than 1 milliamp was from the green LED. So we're at 3 volts. I'm going to put this to the power supply directly right there. And there you can see how bright it is, how much more current it would be using at 3 volts than if we didn't have this setup. So even though we still have a little current flowing through the setup, it's far less than if we were just lighting the LED from the, in this case, a lithium ion battery. That's what we're simulating here directly. So even at 2.5 volts, less than 1 milliamp of current is flowing, but it's a lot more than what would be flowing with the transistor. And it's a good idea to try to stop using the battery at 3 volts if you're using a single cell lithium ion battery. So in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.